Hi there, welcome to my channel. Hope you are doing well. In today's video, we will be solving this Leetcode problem, search insert position. The problem is we are given one sorted array, for example this 1 3 5 6, and we are given one target value. We have to find out if this target value 5 in this case exists in this array. If it exists, then we need to return its index, and if it doesn't exist, then we need to return the index at which it should be inserted. For example, in this case 5 is present here, which is at 0 1 2 second index, so the output will be 2. In the other example, the array is 1 3 5 6 and target is 2. Now 2 is not present here in this array, but if we have to insert this, we should insert it here between 1 and 3. Only then this array will remain in sorted form. So it should be inserted at index 1. Hence the output is 1. The brute force approach to solve this problem will be to run a loop through this array and try to find out if target is there. For example, in this case, we will check the 0th index, then the first index and the second index. In this case, the target is found, so we will return the index here. But in other case, what we will do, we will search at index 0, the value 1 is found. At index 3, value 3 is found, which is greater than 2. Hence, we will insert it at this index to remain in sorted form, that is at first index. Using this approach, it will take time complexity of order of n. In the problem statement itself, it is asked that we should solve this in order of log n time complexity. So how we can do that is using binary search. Now what we do in case of binary search, instead of going one by one like this over the entire array, we will split the array into two halves and see if the middle value, for example 3 in this case, is equal to target or not. So if it is equal to target, we will return that index, but if this value is greater than the target value, then we will search in the first half of the array, and if it is less than the target value, like in this case it is less than 5, so we will repeat the process in second half. Then the array will be splitted from here, because now we are working on the second half of the array, which is this. We found that target is here, 5 is found, so we will return this index. Because in each iteration we are splitting the array into half, the time complexity for this algorithm will be order of log n. Let's try to code the solution now. We will initiate two pointers for binary search, left and right, using a while loop while left is less than right. First we will calculate the mid value, which will be equals to left plus right minus left divided by 2. Now if the element at mid, that is nums mid, is greater than target value, then we will set the right pointer as mid value. In other case, we will search in the right side of the half array, so we will set left as mid plus 1. Once this loop is executed and this condition is not fulfilled anymore, now we can say the whatever index left is representing, that is our output value, so we will return left here. Let's try to run this code. Okay, I used num here. Let's make it nums. I will try again. The sample test cases are fine. Let's submit this. That too worked fine. Let's talk about the time and space complexity of this algorithm. Since we are only having these two variables left and right defined, which will take order of 1 space, overall space complexity of this algorithm will be order of 1. This while loop is executed over the array whose length is length of nums, but with each iteration, we are moving either left or right towards the mid. With every iteration, the array is divided into half, hence its time complexity would be order of log n. That's all about this problem. If you have any better solution or if you have any suggestions to enhance this particular solution, please do let me know in the comment section, and do check out my channel for more such videos. Thank you so much. See you soon. Bye.